So central problems in surface metrology. Okay, so we've alluded to this in engineering, and I'll talk more about that. Science, discovering the past, but understanding surfaces in the sense of the physical sciences as well. And cultural preservation, so records of the past. It's sad actually to go for a walk out in the Tuileries outside the Louvre and see how tough the acid rain has been on the beautiful statues that they have displayed out there. And lots of our archaeological treasures are being destroyed by the air and the rain. So as we want to look at these, correlations are important for the product design, process design, for discovering the past with forensics. How hard did this person lean on the tool, for example, is something we've looked at. So understanding the surfaces like a wetting and heat transfer, mass transfer, and tracking degradation. So correlations are important there. Discrimination, well, quality assurance and quality control. Is this surface good or not? And what do we have to do to fix it? Understanding the surfaces, discrimination is important there, and looking at records of the past. So one of the key questions is, how can we characterize irregularity? To understand how the surface was processed, predict how they're going to perform, and to find strong correlations and confident discriminations. And so these are coming up, and we have developing and developed devices. CT scans are getting better all the time and are important in looking at additive surfaces, for example. Atomic probe microscopes to get down to the very fine scales where there's lots of important fine scale interactions taking place. A little bit coarser, the measuring microscopes like the Sensifar that we had at WPI, the once and future Sensifar. It's been moved out temporarily because nobody can get in to use it anymore. Terrain mapping is another interesting one. So there's a wide range of scales here, from atomic really to planetary. So how do we do it so we can use these things